Hello and welcome everyone. My name is Ssh Borso, and today we'll be continuing on with part 2 out of 3 for our Cloud Security for Beginners course. All right, so to start off with, I want to go over a brief introduction or outline of what we're going to talk about for the next 45 minutes to an hour or so. And really this is meant to build off of what we already discussed so far with part 1 of this series. We have some terminology as a backdrop, and now we're going to start adding in some actual technical components. The main focus today is going to be on virtual machine technology, as in actually deploying machines to our cloud environment, interacting with those machines. When I say cloud environments, I'm talking our CSP, our cloud service provider, AWS and Azure. And I totally understand that not all of you are going to have AWS and Azure resources you can deploy right now, but at some point in time you may, and this will be a great guide to help you walk through the process of doing that, and of course to understand what you're actually doing along the way. That's going to be one of my driving forces here to hopefully clarify some of the ambiguity that happens behind the scenes when you do deploy some of those services. What else we're going to do is deploy security groups, which are cloud speak for firewall rules. And that's a relevancy here because when we do deploy machines to our cloud environments, we have to have some way to access those machines. And the answer to how do we do that is with, among other things, firewall rules, because a machine just being online inside the cloud isn't much value to us or use to us if we can't actually access it. The second kind of component there that has to do with accessing the machine is going to be a service/protocol called SSH, the secure shell, and that'll be a very, very common way that you will access any Linux machine remotely. Okay, whether it's in the cloud, on-prem, at your house, in a virtual machine, as the case may be. SSH is extremely common, and we'll delve into that enough to where you understand kind of the inner workings of what's actually happening and how we use that to connect. And then, of course, we'll actually look at some other services as well before we, kind of take the next plunge into the third part of this mini-series, if you will, of, attacks and defenses and what can happen when we don't deploy secure services or when we deploy a machine to the cloud environment that hasn't been fully locked down. But for now, we'll focus on, one thing at a time. And on that note, thank you all so much for being here and for watching this video. I know a lot of you are watching it after the fact it's been recorded, whether that's through your SANS portal or on YouTube, as the case may be. And based on my request from the last one of these videos, I did ask that you feel free to connect. A lot of you actually did connect, and those of you who did know that I actually do pay attention to LinkedIn and things like that. So if you reach out, there's a pretty good chance I'll respond to you and we can stay in contact if that's something you're so inclined to do so. So who am I? Once again, my name is Ssh Borso, and I am a certified SANS instructor. I am the owner of a company in Denver, Colorado called SpiderSec, and we focus on penetration testing, offensive security, things along those lines. You can Google me, you can Google my company, you can Google SANS if you want to get a little more information and better feel for what we're really all about. For me, it's always been about sharing the knowledge that I have as I gain knowledge myself, because I'm by no means the end-all be-all encyclopedia of knowing everything. There's a lot of things I don't know, and that's the way it's always going to be in the world of cybersecurity and cloud security, IT as a whole. Computer science is such a broad subject. It's very difficult to be really a true expert in all those different fields. A lot of knowledge to have. But I have been in this industry for about 15 or so years now, and I'm happy to share some of my knowledge with you as we go through this. And there's my one PowerPoint slide transition. That's the only one that I'm going to have for you today. All right, let's start off with the recap and the pop quiz, because I know a lot of you did go and watch the first video in this webinar series, part 1. And with that part 1, we talked about a CSP and actually already mentioned that abbreviation once already. A CSP is what? And the correct answer is technically, it is a corporate security policy. I've heard that abbreviation. It is a content security policy if you're in the web world and you deal with content security policies. And of course, in the context of cloud security, it is number 3. But technically, it could be any one of those, just for fun. I regret going down this tangent of making the analogy of what infrastructure as a service is. And I'll tell you why. If you Google infrastructure as a service, or IaaS, is like, and you press enter, you're going to see someone come up with an analogy of it's like renting a car. It's like renting a car because you don't own the infrastructure. You're just paying money for it. You're renting it. It's not actually yours, but you're still responsible for putting on your seatbelt, maintaining the vehicle. I've seen another analogy saying almost the exact same thing. It's like owning a car, where you're responsible for maintaining it and wearing a seatbelt and putting gas in it. And, from a security perspective, so like I said, I kind of regret doing this analogy. It is similar to renting or owning a car. You can make the argument one way or the other. The point here, and I hate to do a recap question like this and give you a vague answer, but hey, I'm telling you straight up, this is what it is. And there's going to be different opinions on this. It's not just black and white, okay? So infrastructure as a service is Azure. It's AWS. It's Google Cloud. It's Oracle Cloud. It's Alibaba's cloud. It's something we don't own, okay? But we are paying money for it. We are using it. And from a security perspective, we are responsible for securing it. So whether you rent a car or you buy a car, you need to put your seatbelt on. And if you don't maintain that vehicle, your belts or hoses or your battery are going to deteriorate over time. So you can make the analogy work however you want to make it work. Just know that that's the underlying meaning of infrastructure as a service. You're paying for a service that someone else provides, and within that service, you have a lot of flexibility with what you can deploy, how you can configure it, and a lot of power, which we're going to actually see some of that today when we do a demo. All right, this is very cut and dry. This is black and white. What is 2FA, which is two-factor authentication, or MFA, multi-factor authentication? The answer is, let's see, it would be a username, password, and a token. Yeah. The reason why is because the word factor. What is a factor? A factor, an example of a factor in this context, is something that you are, as in your retina, your voice, your fingerprint, your DNA. If you want to poke your finger and have the drop of blood come out and check your DNA every time you log into a website. I don't think so, but that is something that you are. That's a factor of authentication. What else? Something you know. I know what my username is. I know what my password is. So something you are, something you know, and also something you have is a third factor. What you have would be a phone with an app like Okta or Google Authenticator or RSA or something like that. And that token on that phone will be your second factor of authentication. So number one is not the correct answer because the username and password, those are two factors, but it's the same factor twice. Something that you know and something that you know. The second one, email, password, URL, same thing. It's three things that you know. A username, password, and a token. Arguably here, we're trying to say the username and password are two things that you know, but the second factor is the token, something that's on your phone that hypothetically an adversary would have to have access to your mobile device to be able to guess what that token is or have access to that token. And that really leads us to the whole point here of why we would care about 2FA or MFA and why this, I'm going to spend a few minutes talking about this because it's relevant. It's important because enabling two-factor or multi-factor authentication on your cloud account, your IAM accounts, your bank accounts, anything that's important to you that supports it is important to do because it drastically, or at least it can drastically increase the amount of effort the adversary has to put into breaking into your account. Cut and dry. That's what we're talking about here. It's not going to be a panacea, the end all be all. You turn on two-factor and you're protected. But it is way, way more challenging for the adversary to be successful with an attack against your account with two-factor when it's implemented properly in most cases. Okay, there's always a workaround, there's always a bypass, there's always a breach that's going to make it less than effective or ideal. But more often than not, here in this day and age, use 2FA if it's important for you. And of course, number 4 is incorrect because a fingerprint is something you have and your voice is also something you have, biometrics, and that's the same factor 2 times. All right, PaaS. What is PaaS? An example of platform as a service. And this too is rather cut and dry. And the answer here is going to be our Beanstalk and Heroku services. You can Google those to learn more about what they actually are. I'm not here to make any sales pitches or anything like that, but those are 2 prime examples. Last question. Because terminology matters, if we want to be correct with what we say, Azure, does the Azure have a portal or does Azure have a console? Does Azure have a CLI or does Azure have a GUI? What's the right terminology here? And the answer is going to be number 1. Azure has a portal and AWS has a console. So when you go to log into Azure, you log into what we call the Azure portal. And when you log into AWS, you log into what we call the console. Does it matter a whole lot? Only if you want to be correct, technically correct when you speak. Other than that, I mean, it's the same thing. Guess what it really is? It's a website. You know what I'm saying? But they all have their little branding and terminology. All right, let's go ahead and move on. A VM, more terminology for you. A virtual machine. This is not specific. Oh, I was about to say it's not specific to your cloud service provider, but it actually is kind of. VM in Azure, virtual machine. In AWS, we call this Ec2, an Ec2 Instance. In general terminology, a VM is kind of universal. You could, whether it's an Ec2 instance or something you're running in VirtualBox or ESXi or Zen or a hypervisor you're using, you can call a VM a VM. Okay, even if it's in AWS, it might not technically be correct. And you may be thinking, well, didn't you just tell us to be technically correct for the portal in the console? Yeah, I did. That's, I guess, why I'm mentioning it here with clear black, white, and red. So now you know exactly what the terminology is called. A virtual machine is an operating system. So it could be Windows, it could be Linux, it could be Mac, it could be Solaris, it could be BSD, it could be Android, it could be iOS. Those are all different operating systems, okay? And this operating system is nothing more than software, right? It's just code that runs on a hardware or platform or some type of, a CPU, some RAM, and some disk. Typically is what's required for an operating system to run, okay? So a virtual machine is an example of an operating system that's running in a virtualized environment, okay? Whether that's like the hypervisors I mentioned a moment ago, pretty much that's the example I'm referring to. So with infrastructure as a service, as an example, a VM is a service that we can deploy. Okay, so let's say I have a machine at my house, I'm looking at it right now, and I want to have a machine in the cloud because I want to have another computer that I can run code or run a website or run a database or run some functions or whatever I want. It's my machine. Okay, maybe I want to crack some password hashes or I want to, have a Tor exit node, whatever. The point is I want to have that capacity and availability to do that in a cloud environment. So what I'll do is what we call spin up or turn on a VM in my cloud environment so I can leverage that machine to do what I need or want to have done. Okay? Now, when we go through that process of turning on a machine and running it and using it, we're met with a few different choices or options that we need to select. Okay? Same thing if we're going to go buy a laptop from the store. We're thinking, okay, how much disk space do I need? Like, do I need 1 terabyte or is 500 gigabytes enough for me? Or maybe even less. How much RAM do I need? Nowadays, maybe 8 gigs, 16 gigs of RAM. That's not really outside the question. Maybe 32. A lot of machines I have physically have 32, 64 gigs of RAM. But that's not free and that's not cheap. Okay. What else? CPUs. same thing. The point here is that just as if we were purchasing a physical machine, we had to make the same choices for hardware specifically, like how much RAM, how much disk space do I need, how many CPUs. We make those same questions and answers, those same selections in our cloud environment, AWS, Azure, as the case may be. Okay. The reason why that's relevant is because the choices you make are going to directly impact what you can do with these machines. Okay, so an underpowered machine isn't going to be ideal for like graphically intense operations. Okay, you can get away with smaller resources if you don't have a big need for a lot of CPU, for example. When you start adding in more resources once again being a bigger hard drive or more RAM or more CPUs, which you totally have the option to do, by the way. You can have a machine with 64 CPUs if you want to. It's going to cost you some money though. Just like if you purchase it physically at a store or online, when you spin up or enable a virtual machine in the cloud environment, same thing. You're using AWS's machines and they're charging you money for those as they are turned on and as they are using CPU cycles. Depending on what service we're talking about, whether it's platform as a service, infrastructure as a service, software as a service, or even function as a service. Okay, so you're kind of making choices of what's going to be appropriate for me, my business, my purposes, and then you're making a choice based on that. And it really does depend on what you're trying to accomplish. Once we make those choices and we say, okay, I want it to be this big of a machine, I want it to be available in this region, which will also be available globally, but the actual hardware that you're choosing to deploy the machine on is physically located in the the United States on the East Coast or the West Coast or another country. It's your choice where that gets deployed at. Once you've gone through the process of selecting those choices, now it's like, okay, cool. It's up, it's running, it's live. How do I access it? What's the point of having a machine if you can't do anything with it, right? So it's not like if I can just go plug a keyboard and mouse into it and use it. I can't just take it out of the box and turn it on. It's like, oh, okay, it's working. I'm going to go set it up now. It's like, no, that's not how it works in the cloud. So to answer the question, we're talking about remote access. Okay, so SSH for Linux boxes and RDP for Windows boxes. And any Unix-like machine is going to be SSH. That's a protocol that we're going to use to remotely administer the machine itself. When we go to configure an Ec2 instance in AWS, we'll be greeted with a menu that looks similar to this, although this has changed just in the last couple days or weeks. This has been updated. And if you watch this video in 2024, what I just said will probably be true again, or even 2023, because AWS likes to change the interface a lot. Does that matter? Not so much if you know what to look for. Okay, I'm bringing it up because it's relevant if you do have a free tier or any AWS account right now. You're like, hey, I'm going to go ahead and kind of step by step, go through this. It's going to look different because they changed the way it looks. Does it matter? Like I said, only a little bit. If you know what you're looking for, it doesn't really matter too much. You're still going to go through the same process, just with different screens and different buttons, okay? But you're still selecting how big is the machine. A micro instance, it has 1 gig of RAM, virtual memory, of course, a virtual CPU. Same concept here. If you want to pay more money or you need more memory, then you select this box right here. And of course, like I said, the interface may look a little bit different, but in essence, that's what we're doing. We're still going through these same choices. The AMI, that's the machine image, as in Linux, Windows, what version of Linux, what version of Windows, how big should it be, configuration options, how many hard drives, add in some metadata, and so on and so forth. In our AWS environment, that's how it works. In Azure, guess what? It works pretty much the same way, only the interface, the portal, right, looks different. Once again, kind of knowing what you're looking at is going to be of value to you. What you also get to see here in the Azure portal are things like, this is how much you expect to pay. And you can calculate that out. You can change the size of this. You need maybe more memory, more CPUs, and it's going to cost you more per hour. What's also of value to note as we go through this process is what you're actually being charged for. So when the machine gets turned on and you use the machine, that's a running machine. You're paying for electricity, you're paying for it to be running. Even if you're not really doing anything with it, you're not logged in, you still get charged for it. Okay? So keep that in mind. The size is going to dictate the price, and it being turned on means you're going to get charged for it. Now, you're like, okay, if I'm not using it, I just turn it off when I'm done. I'm done for the day, I turn off the machine, I don't get charged for it. Yeah, in theory, that's what you'd think, right? But no, not exactly. Okay? And I'm not saying it's good, it's not good or bad, it's just there's more to the conversation there. You won't get charged for the CPU running because it's turned off. But what about that the operating system? Where does it reside at again? Oh yeah, the hard drive. So you want your machine to be available just like you left it when you come back the next day and turn it on, right? So you still have files and folders and whatever else you've done on that machine. That state of that machine is still resident somewhere. Where does it reside at? Resides on a hard drive or a RAID array in the cloud environment. Why does that matter? It matters because you're paying for that storage. Even though you're not using the machine, you're going to be charged money for that storage. Okay? So heads up on that. Other things we see here are exactly what I mentioned a moment ago with AWS. The region, as in the physical location in the US or on the globe somewhere where you want this machine to be deployed at, and the operating system that you want. All right, once again, we have to access the machine somehow. And the way we do that, along with something like SSH, is going to be with thinking through the security implications of what this running machine actually entails. So what does that mean? It means we have more terminology. We have a firewall rule, which is akin to a security group in AWS or a network security group in Azure. And this firewall rule will essentially be put into place to allow our traffic from the internet into the machine itself. So this is kind of tricky for some people new to IT and cloud in general, where we have to understand source and destination. Okay, so if you're at your house or wherever you're at right now, and you want to connect to your machine in AWS, you are the source. You're making the connection request, in this example, to the cloud environment. So the source is your house or wherever you're at right now, and the destination is AWS or Azure. Okay? So what a firewall rule will allow us to do is allow that source of traffic to go through the firewall so we can access the running machine. Okay, that's the whole premise behind this slide that you're looking at right now. We have to allow access. Otherwise, by default, the access is being blocked. So we may have a machine that we turned on, but we can't access it unless the firewall rules allow that access. Okay, it's a built-in security device or functionality, I guess is a better way to say it, that we need to be cognizant of and account for during our configuration of the machine or afterwards. We can always change the firewall rules, whether we're deploying the machine and configuring it step by step, or after it's already turned on, we can change the firewall rules to allow access or block access as we choose and as we see fit. But it's important. It's important because without access, we can't do anything with the machine. Now, once again, I told you the terminology here just a moment ago, security groups versus network security groups. And once again, it's important to understand this is allowing access from your source to the destination. The destination, of course, is your cloud machine or machines, as the case may be. So very important if we want to be able to access our boxes. Here's generally my depiction of what it looks like. You have your machine over here. This is your desktop, your laptop, your phone, whatever it is, and you're using the internet as a network backbone. You're going through the firewall. This is the security group or the network security group, and then you're accessing the virtual machine. So point A, the source is your desktop, going across the internet. If this firewall rule is in place, blocking traffic, then you don't go past this right here. The firewall blocks the access. If you put that network security group or the security group, the firewall rule, put that into place to allow access, then you can SSH into this machine or RDP to this machine. Now, I said access just a couple of seconds ago. Access is vague. What do I mean when I say allow access? I'm specifically referring to ports, services. Okay, I keep on going back to SSH because we're going to use that here in just a second, so you'll see it for yourself. But SSH is the main way we're going to allow access into the environment. So that's port 22 TCP by default. Okay, it could be port 3389 for RDP for Windows boxes. It could be port 25 for SMTP. It could be port 80 or port 443 for web traffic. It could be, right? List goes on. The point is, if you want to allow that type of access to those services, you have to have a firewall rule in place. Now, I'll pause there and ask if there's any questions I can answer. Oh, wow. Oh, don't see any at this moment. Wonder why. All right. No, I'm not going to recap yet. Let's do the demo. All right, let's have some fun. What to do? Let's go ahead and we'll start with AWS. And we'll deploy a machine in AWS, and then we'll SSH into it. Or I will, and you can watch, because it's a lot of fun to do this. So what I've done is I've logged into AWS, and I would search for EC2, which is what we talked about before, the VM service within AWS is called EC2. And I would click on the EC2 button, which I'm going to do right now. And what I'm going to do is deploy a machine. That means I'm going to turn on or spin up a virtual machine, or in this case, an Ec2 instance, right? It's the same thing, inside my AWS environment. So depending on the size of my screen and the version of the interface, some of these buttons are going to move around, but I can choose launch an instance down here. I can look at running instances over here and launch an instance from up here. The point is I want to turn on a machine. So click launch instances, and from here I'll give this machine a name. I'll call it the test box, and I'm going to choose the actual operating system next. So here's the name of the machine, and the Amazon Linux, which is, I believe, based on Red Hat or CentOS, is appropriate. I'll choose that. I could choose, as I mentioned before, it could be Microsoft Windows, it could be Mac OS, it could be other flavors of Linux, and actually I could browse and look for dozens or hundreds of other choices. These are just the popular ones, okay? So Amazon Linux is perfectly fine. I'm also looking down here at this nice little drop-down box. This is free tier eligible. What does that mean? It means it's not going to cost me anything. Well, it might. Yeah, over time it will, but for now it's part of the free tier eligibility, as in if you have a new-ish AWS account, you can launch some machines free of charge for a period of time. 64-bit machine is perfectly fine. So all I've done so far is give it a name. That's default, that's default, that's default, that's default, because 1 CPU, 1 gig of RAM is perfectly adequate for what I'm trying to accomplish here. And then I need to think through how I'm going to log into this machine. That's what's next, okay? And I talked about SSH and the firewall rules before. I have to set up a username, set up a password, or I can set up an SSH key pair. So the difference here, very briefly, is logging in with a password and logging with a key. Arguably, the key is much more secure, so I'm going to actually create a key pair right here and use the default stuff right here. Should be fine. Actually, I'm going to change this to PPK because I'll use PuTTY for this. If you're not familiar with what this is, that's perfectly fine. We don't have time to delve deeply into cryptography and key pairs, but note that we're going to have a public and private key pair. At the end of the day, the public key will be stored on the machine that we're about to deploy, and the private key will be downloaded to my machine. And I'll call this test box for the key pair. I'll create that key pair, and it automatically gets downloaded to my machine right now. All right, this is it's pretty important, so I don't want to gloss over it, right? The way we're going to authenticate this machine is via this key I just downloaded. So this process actually is going to incorporate the other part of the key pair part, the public key, into the CentOS machine. I'm sorry, it's not CentOS, this Amazon Linux machine I'm about to deploy, okay? What's next? Network settings, security group. This is the firewall rules I was referring to before. And we allow SSH traffic from anywhere on the planet. That's what the 0.0.0.0/0 means. It means anywhere on planet Earth over IPv4 can access this machine, which, guess what? Not ideal, okay? from a security perspective, I don't want anyone on the planet to be able to SSH into my machine. Now hold up. Just because I have anywhere via SSH open doesn't mean that anyone can SSH in. They have to have the key or a password. In this case, they have to have the key because by default, password-based authentication will be disabled. Okay, so you have to have the key in most cases to be able to access this machine. So we can lock that down. I can change this to a different IP address, which would be wise to do at some point in time. But for now, I'll leave it default. Everything else default is perfectly fine. I'll say launch the instance. And only a couple seconds later, typically, will be how long this takes. And then I can actually go to the instance itself. And what I want to do next is obtain the IP address of this machine. Okay, and I'll scroll over here a little bit. And the next few seconds, I should have a public IP. And I'll copy this IP address. I always do that. And I'm going to open up an SSH client tool. In this case, it's called PuTTY. And I'll paste that IP address in there, but not before I take the step of loading in my private key into a tool called pagent. And just note that PuTTY and pagent, they kind of work together where I get to load in this key from this test box that I just created a moment ago. And then I'll close it out. What this does is when this SSH session gets initiated, the key gets sent directly to this IP address as part of the authentication process. So if I go ahead and say open, I'm prompted for this fingerprint to say, hey, this is the first time you've ever SSH'd into this machine. Do you trust this machine? Do you trust this fingerprint? You typically say yes, unless you have a reason not to. And the default username for this AMI is ec2-user. And check it out. It actually worked. And I'm not surprised, it should work very, very smoothly. But you never know. Sometimes mistakes have been made. In this case, it's all good. So you can see I was able to successfully authenticate as ec2-user. My key was sent kind of transparently behind the scenes to log me in. And we can see there's 14 different packages that need to be updated. So I'll go ahead, I'll run some updates. And I will move on to rinsing and repeating in the Azure environment, but not before I take a moment to clarify exactly what's going on and what's happening here. From AWS, I went through the process of launching or deploying a new Ec2 instance. It's a new virtual machine. I said I want to be, 1 CPU, 1 gig of RAM, 8 gigs of hard drive space, and Amazon Linux AMI, which is the operating system, and a few other things like that, such as the security groups that were put into place, inbound rules for Part2. This is all relevant and required for this process to work. Okay, so I can turn on a machine, that's fine. But without SSH open, I can't really access it. Without that key pair that I put the effort into talking about and downloading and importing into pagent, I know I'm throwing a lot of terminology at you right now, but you can always pause and rewind and Google it if you need to. This is all required. Without that key pair, I can't SSH in. Okay, because as I mentioned, by default, password-based authentication is disabled on this machine. So I have to use a key to log in. That's not always the case, but in this specific instance, it is. All right, so once this machine is up and running, which it is, I then open up my PuTTY tool. And from there, I could import the key using pagent and once again, SSH in successfully, knowing what the, of course, public IP address is of this machine. Those are like the, 2, 3, 4 things that are required. Turn on the machine, get the public IP, make sure the key has been saved, and then use PuTTY or another tool. Doesn't have to be PuTTY to log in. If you have Mac or you have Linux, you have a command line at your disposal. You can use SSH on the command line. Same thing for Windows 10 and 11 if you have that enabled as well. You don't have to use PuTTY. It's just what I've chosen to use for this specific use case. Let's do it in Azure. Okay, I'll go to Azure and I'll choose virtual machines. And you're going to note that the process is pretty similar. I'm going to say create an Azure virtual machine. The next section here that comes up is what subscription. I'm using this default subscription, and I'll create a new resource group. The way that this works in Azure is the resources associated with this machine are grouped together. As in, I don't just have a virtual machine. It's not thought of the same way in Azure. Okay, in AWS, I went through the process. I need to have a security group in place. I need to have this key pair. I need to have firewall rule. Yeah, things like that. Over here, it's more of, okay, you have a resource group. And guess what? This IP address assigned to this VM is part of this resource group. This firewall rule or network security group is part of this resource group. This new machine is part of the same it's all part of the same group of resources. Okay? Doesn't matter a whole lot. It does for our purposes right now. It's not anything to get hung up on, but just note it's done a little bit differently, the grouping of these things in Azure. I'll say test box Azure as the name of this machine in this environment. A region of Western Europe. I guess that should be fine. I don't see why not. An Ubuntu server. Yeah, I'd rather use CentOS. That should be good. And one virtual CPU, 1 gig of RAM, and the price, $8.76 per month is what I can expect to pay if I keep this thing up and running. Now, I have a choice. I can use a public key or a password, and the public key is the key pair I talked about before, the public and private key. I get the private key, I keep it private. I didn't show it to you guys. And the public key gets stored inside of the configuration files for this machine I'm about to deploy. And then I log in with that with that private key. All right, username. This is also important. You may recall, just based on a few moments ago, the default username for AWS's, what do they call it? The Amazon AMI machine I deployed. The default username was EC2-user. Here is my choice. And Azure user will be the default username. And I guess that's perfectly fine for now. The new key pair, I'll create a new key pair, and just the default test box Azure key pair should be just fine. And then same thing, port 22, open. And here's a little warning though. By the way, once again, anyone on the planet will be able to SSH into this machine if they know the IP address and if they have a key. Okay? Or some other way they can gain access. All right, so everything looks pretty good. It's pretty straightforward. I'll just skip to review and create because I don't care about the disk. The default disk and default settings are all perfectly fine. Once again, I'm just going through the process of here's the operating system I want. Here's the name of the machine. Here's where it's going to be located at. Here's how big it should be. Everything else is kind of just like, okay, don't need to belabor the point. Oh, but I totally don't remember what the username is already. And there's a failed validation. Although, check this out. When we go here to look at it, you can note that I'm not going to change anything. And I'm going to say review and create. And guess what? This time, it's going to pass the validation more than likely, even though I didn't have to go back and change anything. It's a quirk of Azure that I've come to see a lot. All right. If I can only remember the name, go ahead and say create. And you're all thinking, I know what the name is. Okay, so here's the last little part. I said I want to create a default key pair. They give the default username or a default key pair name. I need to download that. Download the private key, create the resource. And now I should have a download option of my test box Azure key.pem. And I'll return to, I'll wait for this to finish deploying. It takes a little bit longer in the Azure environment. And once that finishes, I should be able to see some results of this. But it's going to take a little bit longer to do this. As I'm waiting for that, what I'm going to do next is open up a tool called KeyGen. P-Agent. No, it's PuttyGen is what it's called in this operating system. And I need to convert that PEM file that I just downloaded, which is my key. I'm going to convert this over to the PPK output that the Putty tool, the P-Agent tool need to have. So I'll say their private key, and I'll call it Azure testbox.ppk, and then I'll go through the process of opening up P-Agent again, and I'll add that new key into pagent, Azure test box. If this is confusing, I understand. The point is the default format of the key pair that Azure created for me is not in the correct format that PuTTY wants it to be in. Okay, it's like, here's a key, but it's formatted in a way that PuTTY doesn't understand. So I had to convert it. Okay, that's all that process was. And of course, if it's a little bit tricky, like, hey, how'd you actually go about doing that? You can always pause and go back. Now I'm gonna go ahead and check out this test box Azure. It's still creating right now, as I thought it might still be. So I don't know if there's an IP address. There is, which is something I want to take a note of. So we need to log into that. And I'm also going to go through the process of trying to remember what the name I gave this thing was. And I think there's an option over here, and I always screw this up, especially during a live demo, where it's going to tell me the name of that user I just created a second ago. I can never remember off the top of my head where it is. So I'm going to have to click a couple different buttons. Geez, I should take my own recommendations, pause, and go back and look. What the heck? I think it was like Azure user or Azure box or something. But those of you watching this are like, we know what it is. It's identity. No, that's not it. It's under connect, I think. Azure user. Okay, cool. Now, this is a good note for you as well. This is where you can go check if you forget your username, what your username actually is, and also see the IP address again. All right, we're good to go. I'm gonna go ahead and say in PuTTY, create a new session in PuTTY, and I'm gonna give it the IP address, which I copied already. I'm just gonna paste it in right there. I'm going to open this up, and remember Azure user is the username. Same prompt from before. Azure user. Press enter, and if the machine's up and running, it's good to go. We're ready to rock and roll. And as you can see, we are definitely good to go. So I'll make this font just a little bit bigger so you can see it. See the fruit of all of our effort and labor. We have successfully logged into this machine as well, using the key that we have downloaded and converted using PuTTYgen and PuTTY and pagent. So a few different things there. You don't have to use PuTTY or PuTTYgen or pagent, those three different tools all rolled into one kind of. They're three different applications, but you don't have to use those. Like I said, if you have Mac or Linux machine, or even your actual Windows box nowadays may have SSH client installed. But that's what that's all about. We're SSHing in using a client application. In this case, the client I've chosen to use is a client called PuTTY. You don't have to use PuTTY, but I digress. All right, so what's the point? Now we're logged in. Port 22 is open. Anyone can access this. I did communicate clearly that you can access it. Like, yeah, port 22 is open. You all know the IP address. You could try to brute force your way and gain access right now, but it's not always going to work. You have to have the key in this case to gain access. Well, in most cases, but there's always something else that could come up. And that's how we deploy machines into our Azure and AWS environments. So a lot of things go into this, clearly. Setting up the machine, how big should it be, how much money you want to pay for, what am I going to use the machine for, things like that. You got to answer those questions to understand the choices that you're going to end up ultimately making. And then remote access. I talked about SSH and keys and PuTTY, probably a lot more than maybe you even wanted to, but there's value in doing that because it's part of the real world. Okay, there's like, hey, he did a demo and that's how he chose to do it, but I'm going to do it differently. It's like, no, you're not. If you deploy a machine, that's 95% of the time how you're going to access it remotely. If you have remote access available, it's going to be RDP if it's Windows box, or it's going to be SSH if it's Linux box. And if it's SSH, you have a password, which is less than secure, or you have a key, which is exactly what I showed you how to do. So you don't have a whole lot of options, that's my point. But you do have other options. To be straight up, you could, if you want to access this Ec2 instance right here, you click this checkbox next to it in AWS. You could say connect. And you could use the console itself to connect to this machine within its own little console within a console almost. And there we go. Perfectly valid session. So there are other ways to do it. You got to choose what's best for you. And of course, troubleshooting, I forgot the username of my Azure machine. I had to go, that wasn't a big troubleshoot, but it was more remembering where I could find that information at. We did set up firewall rules. It may have been done for us by default as part of the process, but without port 22 open by default for SSH, we're not accessing it. Okay, so that's another very important thing to do. As far as the tools for the job go, I think I've already belabored the point of SSH and the client and the keys, but that's a very valid point that's going to be valuable for you to learn more about as you continue your understanding and progress in a cloud environment. And that's the other big thing, understanding what's going on. With that, that's about all the time we have, all the fun time we have for today. Are there any questions that I can answer? And if you're watching this on YouTube or something, you can put comments in the comment section, probably, and there's a chance I might even respond to it. So who knows? And of course, if I don't, there are other ways to contact me. Heads up, if this is interesting to you, there is a new course from SANS. It's called Sec 388. It's a course I've written myself. It's Introduction to Cloud Computing and Security. So if this was fun for you or interesting to you or complex, and you want to kind of break that down, learn some more terminology, learn about more services, learn how you can incorporate security into securing these services, learn more about why you use a key versus a password, learn more about IAM, learn more about, there's so many different things we could delve into. If you're interested in this, check out Sec 388. And like I said, there are other ways to contact me. LinkedIn, I'm pretty active there, and Twitter, you can welcome to follow me. And if I don't answer your question, do hit me up on LinkedIn. There's a pretty good chance I will. Other than that, thank you for your time. I hope you enjoyed this and hope to see you around.